Hi, I'm Isabel Yermolov, and my research project is about the physics of eyes. My question for my research project was, how do our eyes differentiate colors and comprehend the shape of objects? So I have learned in my physics class that light travels in waves and take the form of electromagnetic radiation. Light rays allow us to see color and the shape of objects, and our eyes are able to refract light. But the further questions I had were, what determines if a color will be reflected? How is light refracted and focused? Why is the image in our eye initially reflected upside down? What determines if a person is near or farsighted? How do contact lenses in glasses correct one's vision? And do our eyes have a different index of refraction? The reflection of color. As light rays encounter an object from a light source such as the sun or a light bulb, some colors are absorbed and others are reflected. The true color of an object is what is reflected. The only way to know the true color of an object is to put into sunlight or white light, because the color of an object can be determined by the lighting in its environment. If you have a red ball that is placed in a blue light, the red ball may appear darker than it does when it's placed in sunlight. In addition, lighter objects don't heat up as fast as darker objects do. Darker objects absorb more different wavelengths of light energy, but lighter color objects reflect the light of most wavelengths. You may have seen a prism. Prisms have many different angles which refract light, so that when the sun shines through it, the whole entire visible light spectrum is unleashed. This is the visible light spectrum chart. These are the different colors that you may see when you see light shine through a prism. As you can see, every color has a different wavelength. A wavelength is the distance between the crest of a wave or between similar positions on a wave. Colors such as blue and purple have a shorter wavelength, but they have a higher energy, while colors such as red and orange, they have a longer wavelength, but a lower energy. How light is refracted and focused. There are many components in our eye that help us in seeing. On the frontermost part of the eye, we have our cornea, which is a hard membrane that refracts most of the light. Behind the cornea is our disc, which helps focus the light onto the retina. The most important parts for one's vision is the length of one's eye, the radius of the cornea, and the radius of the lens. If there are problems with any of these, that might result in blurry vision. When light shines through the cornea and the lens, the image is projected onto the retina. Inverted image. As light rays enter our eye, they are refracted, and our eye acts as a convex lens. The convex lens converges the rays of light into a single point, and the image is projected upside down. Our brain then takes the inverted image and flips it right side up. Vision loss. Blurry vision is usually caused by refractive errors. Hyperopia is usually known as farsightedness and results from the incoming image being focused behind the retina. Myopia is commonly known as nearsightedness. It results from the incoming image being focused in front of the retina. Those with hyperopia have a hard time seeing objects that are near, while those with myopia have a hard time seeing objects that are further away. Astigmatism is caused by a distortion of the cornea, and there are two focal points. How corrective lenses help. Corrective lenses adjust the focal point to compensate for the eye's inability to focus the incoming image onto the retina. For those with myopia, a minus lens is utilized and the focus is pushed back. As the strength of the lens increases, the focal point becomes longer. A minus lens looks like this and is a concave lens. For those with hyperopia, a plus lens is used to move the focus forwards. As the strength of the plus lens increases, the focal point becomes shorter. A plus lens looks like this and is a convex lens. When one has astigmatism, a cylindrical lens focuses light into a line instead of a point. In addition, one focal point is created instead of two. As you can see, the index of refraction is very similar between the structures of the eye and water. I created this table so that you can easily see how the values compare. Many eye structures have refractive properties that are somewhat similar to water, and they can bend light rays into a precise point of focus that help us see clearly. Conclusion. There are many components in our eyes that allow us to see colors and perceive the shape of objects. We are able to see many different types of colors as they take form of wavelengths of electromagnetic radiation. As light rays reflect off an object, the light rays enter our eye. The image, as well as the color, is refracted through the cornea and lens and many other structures of our eyes. The image is projected upside down, and our brain is able to interpret the image, and that is how we see. Thank you for listening.